EE World, we are in Orlando at the APEC conference show, and Cody from WurthElectronics is going to show us this EMI setup that you've got here. Cody, why don't you tell us what you're doing here?
Yeah, of course. So here we have kind of our DC connection in, which goes into our listen. Then we have a configurable filter board into a flyback that's currently having some EMI issues into an active load, just to help regulate it and create more of those high peaks.
Okay, so what's the active load? It's just, I mean, you got some LEDs on there. And
Yep,
it's
LEDs.
Just, it's just
we
to
can
have some kind of load.
change how much current's coming in and out.
Oh, okay.
In this case, so
okay.
So here we can see, if we take a look at our screen, we got multiple points kind of failing across our line and failing EMI.
Okay. So yeah, here's the line right there.
Yep.
That looks like the standard. That's where you want to be below.
Yep. And our first one's the fundamental frequency, which is right where we're switching at. So that's causing us issues in this case.
Yep. And that's going to just create. You're going to have harmonics and so on, and eventually you reach a point out here where everything's above.
Yep.
Everything's above the line.
Lots of problems. So now I can show you a couple of things. Yeah. We'll take a look at how a common mode choke can help this. So we have here a manganese zinc common mode choke on this larger size, and it should be able to help improve quite a bit the EMI performance.
Okay,
so we'll crank it back up here.
Okay, now I'm looking at the scope. We're going to trigger the scope.
Save the trace. And we can see if the green line, now it's quite a bit lower. We have still a few close peaks, but very close to passing design.
We saw that just as it came on. You could see the new trace down here.
Yep.
There. So yep, common mode chokes will certainly help. Common mode currents are always a problem in EMI.
Always causing issues.
Okay.
One of the cool things though is here's a similar part that's a nanocrystalline core. So it's actually about the same inductance and the same rated current, but it's half the size. So it can greatly help with that power density. And we can kind of show how that one could help with this design in this case and make it a smaller design for the customer.
Somebody had fun building this setup.
I know. It's a lot of fun, kind of like Legos, plugging and playing the whole way.
Plug them in. Okay, so now we're going to look again and see the difference again. I'm going to trigger the scope, and you'll see the difference.
So here now it's the orange line. So in the low frequencies, we have a nice attenuation. It did get a little higher, and the main reason for this is with a smaller part, the common mode chokes will still have some differential impedance, which will help with the noise. But since it was smaller, it has a little less of that.
Yep.
But easy way to fix that is just a small little X cap we got here.
Okay,
we just pop that right in.
Add it right on top, and we'll trigger the scope again and see what happens.
And here you go. Now the orange line's way below even the other one before. So much smaller solution, but better performance in EMI in this case.
Okay, very good. Thank you, Cody.